next session on MATLAB basics. In this session, we are going to discuss about the vector operations. First, we'll discuss about addition and subtraction of vectors. You can add or subtract two vectors. Both the operand vectors must be of the same type and have same number of elements. Let's see an example. Vector A has 5 elements and vector B also has 5 elements, which means they have the same number of elements and they are of the same type, means it is only one row and 5 columns for each of them. Next, if you see, C is the addition of A and B and D is the subtraction of the two vectors. Display C will display the result and display D will display the result of A minus B. So let's take this into MATLAB and see the result. You can see here, this first one is C, that is displayed A plus B, and this is D, that is displayed A minus B. Next, we'll talk about scalar multiplication of vectors. When you multiply a vector by a number, it is called the scalar multiplication. Scalar multiplication produces a new vector of same type, which means the number of rows and columns remain the same, with each element of the original vector multiplied by the number. So suppose V is a vector which consists of these four numbers, and if M is the scalar multiplication obtained by multiplying each element by the number 5, then we will see what is the result in MATLAB. You can see the first number is 12 multiplied with 5, 34 multiplied with 5, 10 multiplied with 5 and 8 multiplied with 5. And this will lead to one row and 4 columns, which means there are 4 elements as that of vector V. Next, we'll talk about transpose of a vector. The transpose operation changes a column vector into a row vector and vice versa. The transpose operation is represented by a single quote, dash. Example, R is 1, 2, 3, 4 and TR is R dash. V is a vector 5, 6, 7, 8 and transpose is V dash. So let's display this transpose of row vector and transpose of column vector. We know that the transpose of row vector is a column vector and the transpose of a column vector is a row vector. You can see here, this row vector has become a column and this column vector has become a row. Next, we'll talk about appending vectors. MATLAB allows you to append vectors together to create new vectors. If you have two row vectors R1 and R2 with n and m number of elements, to create a row vector R of n plus m elements, by appending these vectors, you write R is equal to R1, R2. You can also create a matrix by appending two vectors. The vector R2 will be the second row of the matrix. You can also write it this way, R is equal to R1 semicolon R2. So you will have two rows now. However, to do this, both the vectors should have same number of elements. This is very important. Similarly, you can append two column vectors C1 and C2 with n and m number of elements to create a column vector C of n plus m elements. By appending two vectors, you write C is equal to C1 semicolon C2. You can also create a matrix C by appending these two vectors. The vector C2 can be the second column of the matrix C is equal to C1, C2. However, to do this, both the vectors should have the same number of elements. So this is an example, R1 is one vector, R2 is another vector. This is appending two vectors, and here these two vectors are now in the form of two different rows. Similarly, C1 is one column vector, C2 is another column vector, C is appending these two, and here you can write two columns side by side. So we will just put this into MATLAB and see the result. You can see here R1 and R2 will be appended, and also they can be written as two different rows. Now let's take the example of the column vector. You can see here C1 and C2, they have been appended together, and here they have been written side by side. This is the way to do. Next, we will discuss about finding the magnitude of a vector. Magnitude of a vector V with elements V1, V2, V3 up to Vn is given by the equation V is equal to root of V1 square plus V2 square plus V3 square plus dot 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 up to Vn square. You need to take the following steps to calculate the magnitude of a vector. Take the product of the vector with itself using array multiplication dot star. This produces a vector SV whose elements are squares of the elements of vector V. So SV is V into V. You can see here. Next, use the sum function to get the sum of squares of elements of vector V. This is also called the dot product of vector V. So dp is sum of SV, the one we have found. Use the square root function to get the square root of the sum, which is also the magnitude of the vector V. So magnitude will be square root of dp. So we'll see an example here. V is taking numbers from 1 to 20 with a step of 2. So 1, 3, 5, 7, in that way up to 20. First we'll find SV. That will be V into V. That is, each element of V is multiplied with the element of V itself. Then we find dp is the sum of these squares. And finally we'll find the magnitude by square root of dp. First display will display the term and last will display the value. So let's take this into MATLAB. You can see here, this is V, SV, dV, dp, the magnitude. The display of this magnitude has been done here, and this value of magnitude has been shown here. Next, we'll talk about vector dot product. Dot product of two vectors A is equal to A1, A2 up to AN and B, B1, B2 up to Bn is given by A dot B is equal to summation of AI into Bi, which means each element of A, say a particular element A1 into B1, A2 into B2, and they are just added. Dot product of these two vectors A and B is calculated using the dot function. So you can also use this alternately, dot A comma B. So this is an example given. V1 and V2 are the two vectors. Finding dot product, dot V1 comma V2, and this is the display done. So we can just copy it and take it to MATLAB and see the result. The dot product is 20. Next, we'll see vectors with uniformly spaced elements. MATLAB allows you to create a vector with uniformly spaced elements. To create a vector V with the first element F, last element L, and the difference between the elements is any real number N, we write vector is F is to N is to L. So 1 is to 20 is the number series and 2 is the step value. So the numbers will be 1, 3, 5, 7 accordingly. If you're finding square of this element V, so it is V dot raised to 2, and you can just display this value. We'll check it in MATLAB. You can see here, this is the spaced vector and this is the square. So it's just found by squaring each number, you can say. With this, I end the session. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.